a sheet of A3 will have double the area of a sheet of A4 paper, because if you put two sheets of A4 paper side by side, you basically get the same size as an A3 sheet, same dimensions. But this question doesn't require you to know that, because it actually tells you. It tells you that if you've got a photograph that fits on a sheet of A4, when you've enlarged it, it will now fit on a sheet of A3, and the area has been almost exactly doubled. The almost exactly is there to allow for the fact that maybe some slight inaccuracy where in the actual photocopying process, but it's been enlarged and the area has been doubled. Now, if the photograph has been enlarged, then we're not distorting it. The enlarged version is similar to the original version. So the A3 enlarged version is similar to the A4 version, and the area scale factor therefore is 2, and from that we can work out the enlargement scale factor. So we've got the area scale factor is 2, and you should know that the area scale factor is the enlargement scale factor squared. Alright, so the enlargement scale factor squared gives you the area scale factor. So if the area scale factor is 2, the enlargement scale factor must be in the square root of 2, because the square root of 2 times square root of 2 is 2. So if the enlargement scale factor is root 2, and the width of the photograph after enlargement is 28, then the width of the photograph before the enlargement has got to be the width before the enlargement has got to be 28 centimeters divided by the enlargement scale factor, so divided by the square root of 2, and you get 19.8 centimeters. I've worked that to the nearest millimeter. In question 12, part A is testing whether you remember or know the factorization of a difference of 2 squared. You've got x squared subtract 9 squared. So it's such a common factorization that really you should memorize or be able to recognize and then be able to factorize just by looking. So x squared minus 81 is x plus 9 multiplied by x minus 9. Right, so when you expand it, you'll get an x squared term, which is what we wanted, plus a 9x minus a 9x gives you 0x, which is what you want, and then plus 9 times minus 9 is minus 81. Now, part B says use your results to help you to factorize x to the 4th minus 81. You're not quite using this result, but you're using this idea. And the idea is that this is also a difference of 2 squares after a fashion. You can think of x to the 4th as x squared squared, and you can think of 81 as 9 squared. So x squared squared, take away 9 squared, would be the same as x squared plus 9 multiplied by x squared minus 9. Let's just check. X squared times x squared is x to the 4th, plus a 9x squared minus 9x squared gives me no x squared, 0x squared term, and then minus 81 at the end. So that does multiply out to give x to the 4th minus 81. But if you read carefully, it says to help you to factorize fully. So fully suggests that there's often another step, and here indeed there is. X squared plus 9 doesn't factorize any further, but x squared minus 9 does, because again it's a difference of 2 squares. It factorizes to give x plus 3 multiplied by x minus 3. And so that's the final answer. The key to doing question 13 is recognizing that you've got even powers of x. You've got x to the 4th term, an x squared term, and a number term. The syllabus doesn't specifically talk about solving quartic equations where the highest power is x to the 4th. We're not really taught specifically how to solve any old quartic equation. So the key to doing this question is to think, well, what sort of equations do I know how to solve that involve perhaps 3 terms and powers? And the simple answer is quadratics. So you think, can I rewrite this so that it becomes a quadratic equation that I can actually solve? And the answer is yes, you can. If we, instead of using x squared here, we had, say, a single letter, say a y, instead of having x to the fourth there, we replace that with y squared, then we've got something that we can work with. So I'm going to let y equals x squared, just to make life a bit simpler to understand. So x to the fourth would be x squared times x squared, so that's y squared. X squared would be just a y, so I get y squared minus 13y plus 36 equals 0. So in effect, what I've noticed is that this quartic equation, Q-U-A-R-T-I-6, this quartic equation is actually a quadratic equation in x squared. Now, I'm going to solve this equation to work out what y is, and then I'm going to work out the values of x that go with the particular values of y that I find out. So, how does this factorize? Well, it actually factorizes into two brackets, a y in each, and I'm going to use 9 and 4, minus 9 and minus 4. Alright, because minus 9 and minus 4 will give you the minus 13, so minus 9y, minus 4y is minus 13y. Minus 9 times minus 4 is plus 36, so I get the number term correct, and y times y is y squared. So that's the factorized form of y squared minus 13y plus 36. So from that, I can see that either y minus 9 is 0, which makes y equals 9, or y minus 4 is 0, in which case we get y equals 4. So I now need to look for the case where y equals 9, see what values x could have. Then I look at the case when y equals 4, see what values x could have. So when y is 9, we have x squared equals 9. So when we square root, we have a positive and a negative square root of 9. X is plus or minus 3. And when y is 4, we have x squared equals 4. So when we square root, we get x is plus or minus 2. So we have 4 solutions altogether. So the solutions are plus or minus 2 and plus or minus 3. So 4 possible solutions altogether.